The zero product property is simply a method of being able to solve quadratics. And quadratics are when you have an exponent of 2, and oftentimes they're factored already. So if we have it factored, we can set it equal to 0, as we've done here. And now we just take each factor and solve. So I have x, or 3x minus 1 equals 0, so I solve by adding 1 to both sides, divide by 3, and I get x equals 1/3. And then if I do, let me erase this so I can do a different color here. So I have x plus 2 equals 0, and I solve by just subtracting 2, so I get x equals a negative 2. So my two answers are x equals 1/3 and x equals negative 2. So we've solved this quadratic, and we use factors to do that. Now, the reason we've used or did factoring is so we can actually solve this. So if I have this quadratic, I need to factor it. To factor it, I have to have everything on the same side. So I'm going to take my x squared, I'm going to minus the 6x, and add the 9 equals 0. So basically, I've moved these to the left and set it equal to 0. Once I have it equal to 0, I can now factor this. So I'm going to go through my factoring methods. And my factoring methods are what two numbers give me 9 and add up to negative 6. Well, they are minus 3 and minus 3. Because negative 3 times negative 3 is a positive 9. When I add them up, I get a negative 6. Now, once I have my factors, I set each factor equal to 0 and solve, which in this case, it's going to be the exact same number. So my answer is 3. So here's another example where we have to factor quadratic, and to do that we need to get everything on the same side. So I'm always going to try to get where my x squared is positive if possible. So I'm going to minus the 2x, and now that equals 0. So now I factor this. First thing we always want to do is check greatest common factor. Well, x is the greatest common factor. So I factor out the x, so I get 3x minus 2 equals 0. And once again, I'm going to set each factor, here's my first factor, equal to 0. So x equals 0, that's one answer. And now I'll do the other factor, which is 3x minus 2 equals 0. And so I solve my equation, divide by 3. And in this case, I get a fraction, which is fine. And so I have my second answer. So there's my two answers to the quadratics. So we want to factor or use real-world applications. So here's modeling the motion. Here's our formula that's given. And we want to know how long will it take for the ball to hit the ground. Well, the ground is 0 height. So now we know the h. So I'm going to substitute the h with a 0, negative 16t squared plus 48t plus 160, and I'm going to go through my factoring methods. Well, the first thing is when I have a negative, I'm going to factor out negative with the greatest common factor. Well, 16 goes into all of them. So if I take out a negative 16, I'm going to get t squared minus, I believe that is 3t, and then negative 16 to 160 is a negative 10. Now, I have to continue to factor, so I'm going to factor my trinomial, and that becomes the t's get split. What two numbers multiply to give me a negative 10 and add up to a negative 3? They happen to be a negative 5 and a positive 2. So now I have it all factored, and it now equals 0. So I can set each factor 0. Well, negative 16, we don't have to worry about that, but we do have to worry about the other two. So I'm going to go t minus 5 equals 0. So t equals 5. And then t plus 2 equals 0, and I get t equals negative 2. Now, time cannot be a negative, so we can automatically eliminate that. So the answer is 5, or 5 seconds. How long will it take the ball? It'll take 5 seconds.